Welcome back everyone to another Femap tutorial, and here we're gonna illustrate a transient analysis problem. We're gonna set up this right here, the one-dimensional bar, when we're gonna apply force at the end, which is time dependent. It's 1000 and it's constant, but you can see it's time dependent. Okay, very good. So we're gonna apply the solution 109, the direct integration method solver, and let's get started. We're gonna go to model and set up our material. It's gonna, let's call it material 1, type isotropic, it's fine. Young modulus, the problem was calling for 30E6. We'll leave this as 0.33, and mass density also was given, so 0.00073. There you go. And that should do it for that. Cancel, go to model, property, my rod, material type, what we just defined, material 1, element property type, we're going to be working with a rod. Okay, and the area was 1 inch square, and that's it. There you go. Cancel. Let's draw our geometry. So go to the geometry, curve line, and let's use coordinates. The first point at the origin 0, 0, 0. Okay, second one, let's go along the x-axis, and the problem said each element, we're gonna have 2 elements and each element should have 100 length, so we're gonna make it a 200 length overall. Okay, cancel. Now let's go ahead and mesh our geometry. So mesh, first we're gonna seed it, right? So mesh control, size along curve, select our curve. Okay, we said we need 2 elements, so put a 2 right there, equal elements, and okay, cancel. And now we're gonna go ahead and actually mesh geometry, curve, select the curve. Okay, make sure you select the property my rod. If you have multiple, you know, it might pick the wrong one, so we only have one, my rod. And okay, and now we see if you press Ctrl Q, here's your visibility options, click on labels, and if we turn everything off, if we want to see the geometry, we can set points and the curve, right? If you want to see maybe boundary, surface, all kind of stuff, these are all belonging to the geometry. If we click them off, now if I want to see parts of the mesh, node, there you go, elements, we see we have 2 elements, right? Good. I'm gonna leave the mesh identities up, so okay. Next up, let's set up our boundary conditions. So we're gonna go to model, constraint, nodal. You can do nodal or point. Let's do nodal for this time. Title, what is it? Let's call it left. Okay, click this one. Okay, title, left. Oh, I should have not called the other one. The other one was boundary conditions, not left. Okay, we'll change it. We can change it right here. So here we're gonna have a pin. There you go. Okay, and on this side we're gonna have, this is right. We're gonna have a roller in the x direction, so we're gonna zero these ones out. Okay, and cancel. And let me go back here and see these 2 left and right. I didn't want to call this one left, so let's rename that. Call it BC, boundary conditions. There you go, good. Also, I want to see what kind of restrictions are on these nodes, so go back to Ctrl Q, labels, and let's see where the constraints down here, and if we click them, then you will see that we have a pin 1, 2, 3, and we have a roller with 2 and 3 blocked off. Okay, now let's go ahead and work on setting up our load. remember our load was a time dependent function. Even though it's a straight line of 1,000, it's still a function. Okay, so we're gonna go right here to functions, or you can also go to model and right here function, and here is our setup window. Title, call it force or whatever you want to call it, force 1. And here type, this will be a time dependent function. All kind of functions can be set up here, but for us right here in the beginning, a very first one, number 1, something versus time, right? So that's what we're gonna set up for us. Look in the videos links or the playlist. There's another video where we go into setting things up with an equation. In this one, we're gonna, since the function is a simple line, we're gonna set it up with single values. So what I'm gonna do is set determine 2 points, one here and one further down in the timeline, and also the same value. So 0 at time 0, we're gonna call 1,000, add, and further down, you see here it makes a table of our values. So further down, let's say at 1 second, it's also 1,000, right? It didn't change, a straight line. So add, see, table, building our table. We could keep adding stuff and changing it however we want, and it would just tabulate it right here. But this is all we need for our setup. If you would want it to, if you leave it like this and you would run your analysis past 1 second, it will continue the tangent of whatever your last point was. If you wanted the force, for example, to stop at 1, you would need to put in a value showing it to go down to 0, and your last value defined needs to be 0, because then Femap, if you go past that, it will take it from there. Oh, your last value was 0, so then it continues from 0. Okay, so remember that, and I believe that would be it. We can click OK, cancel. Okay, and let's go ahead and actually set up the load, right? We just defined the function, we don't have the load set up yet. So go to model, load, so let's set it up either on the point or the node. Usually it's good to set it up on the point because that belongs to the geometry, but since I defined the other one, the constraints on the mesh, I'm gonna define the loads on the mesh as well. So I'm gonna put it on node. Let's pick the point. Okay, let's gonna call it ft1 and force, right? And here we can go and pick the function that we just defined in our function, right? Force 1. And we also need to define here, but this will be understood as a multiplying factor with the function that we found here. So if we don't want any change from how we defined it, then all you do is put a 1, right? Because then you multiply your function by 1. If for some reason you want more, maybe 10 times the function that we had defined. So for us, 1 time is just fine, and that should do it. Okay, cancel, and we can see it is defined. We can go to Control Q, forces, and right here, there you go, we have our force defined, done, and I believe we are ready to run our analysis. One quick note, if you want to visualize or double check maybe your function, how is it or how did it look, go back here to charting, double click, it'll open up. Go right here, chart data series manager, open it up, new data series. We'll call our F, our force, vector versus set, and nope, no function right here, our function that we defined, force 1. Okay, and cancel that out, done, and there you go. See, we have a nice visualization of our function. If it was more complex, you could check it that, hey, okay, good, everything's fine. Just a little side note. Go to model, analysis, new title rod with solution 109, and we're gonna pick not static, we're gonna pick the number 3, transient dynamic time history. Okay, we can open up options. Alright, dynamics not defined. Make sure you go in here. Since this is a transient analysis, we need to define the time frames that we are working with. So number of time steps, the problem did not give it, so I'm gonna define it 1000 times step, time per step, so how big of a time increment to calculate at a time. So since it was not given, I'm gonna define it like this. It's a very small number of time, and one each interval. How many, which as it's gonna run the analysis, it's gonna do calculations at every single time step, right? And do I want it to output the result at every single calculation? Or maybe if you're doing a massive calculation of millions of time steps, you could do like no, I don't want every single one, I just want every 100 or every 1000 calculation to be recorded, because this will define how big your output files will be. Okay, if you're doing big things, you're gonna have some big sizes. For us, doesn't really matter because it's a very small, insignificant amount of data. But yeah, that's keep in mind. So okay, and now we are done here. We can go ahead and run our analysis. And if we didn't mess up anything, then we should get an all clear down here. Let's see. So now it's doing the time steps one by one, calculating as it progresses through time. Come on. And woohoo, complete. That means we didn't goof up anything. So we have our analysis completed. Now let's take a look at what we've got. Let's do some charting. And remember, we charted our forcing function. Let's do another one. New data series. This will be let's call it the displacement, right? We're gonna there you go. So we're gonna visualize how this end of the rod behaves according to this time function. Vector versus set, output set value. Let's visualize the translation in the x direction, and location. Where do we want it? Right here, this one, this location. And that's it. Okay, and let's see what do we get. We can cancel that one out. Oh, we don't want this one on it. Let's delete that one. We had enough of that, and there you go. Now it shows what we got from our result, from our analysis, because our force was 1000, so our displacement of 0.00, it was not vibing on the same chart, right? It was way too different numbers. So now we can see how our end behaves according in this 1 second, 0 to 1, right here. We can also see that we started from 0, right? Our initial condition was 0 displacement. We didn't define any forced displacement, and after it was displaced, we can see its behavior didn't have any damping, so therefore it's an undamped, forced undamped vibration. Now here we could also request, I don't think it requested the, let's see, new data series. Do we have the velocities? Let's see, we don't have velocities, just acceleration, displacement. So yeah, well, if Femap doesn't give it to you, let's see what could we do to get them. So we would have to probably do a brand new analysis. Go to analysis, and let's do a new one. This one will be rod. So let's say 102. Okay, and keep these the same. Okay, I believe we need to check. Yep, not defined. So let's define these two. Same. We're not gonna change anything here. Each of them. Okay, but we need to go to output requests right here. If we open this one, double click on the output requests. Come on, acceleration, displacement, no. Okay, yeah, so double click on the one of these. This window opens, and as we can see here, see, velocity is not checked. So click on that one, and if we run our analysis again, now we should get what we want, right? So 102, analyze. Let's let it do its thing again. And complete. Okay, we can close this guy off, and let's go ahead and new data series, title, I'm just gonna call it the V, vector versus set, output. I'm gonna click this off. I don't want all of them, so you're gonna have to come here and make sure you select, because we have multiple analyses now, right? So we don't want everything displayed, we want the second one, this one here. And now, as you can see, we have translation, rotation, and we don't jump straight to acceleration. We have a bunch of velocities here, right? So let's do T1 velocity, and again I want it on location 3. Okay, and here we have it. Cancel that one out. Let me make this a little bit bigger so we can see it. There you have it. So the displacement and velocity, displacement in green, which is quite small, but velocity is bigger, so we can still see it. And if we wanna, where did we start off? Remember initial condition, what was it? It was 0, so we can verify that, right? There you go, it started from 0, and then how it progressed through time. For those of you who are interested a bit more about the inner workings of Femap, so we can go back to our analysis, and let's take a look at our input cards. This is where all the magic happens as far as Femap is concerned, right? So these are called our cards. We have up here, this is the case control section. In the beginning we have the executive area where we defined what kind of analysis are we running. Like here you can see the solution of the transient. Here our output files, like what are we going to be requesting to output. Down here, this is the bulk section. This is where all our constraints, our loads, our what kind of details of our setup we can find. Let's take a look at what we can read out of here. Here we can see some details about our force. See the load. Here SPC, these are our constraints. Remember, one side we had a constraint of 1, 2, 3, which was a pin. The other one, node 3. These are the identities of the nodes. We only had a 2, 3, right? We had a roller in the x direction. Let's see, this is the properties of our rod. The element that we used, it was a rod. Its area, we can remember it was a 1. The material that we set up, we definitely can recognize some values from here, right? We had to enter these, the Poisson ratio, E, the density, that kind of stuff, the grid details, the connections between our rods. So yeah, several things, even if we are not extremely familiar, we can recognize. Okay, we have other videos on our cards on how Femap operates and what each of these sections mean, at least the most important ones. Like see right here, name of our function, time dependent set, So you can recognize quite a few details that you worked with, and you can see how things operate. Yeah. And I believe that should do it for this video. We covered pretty much anything. You can go ahead and go to view, select, or options. We can visualize certain things of our result. Not that one. View, select here the deform, contour, right? And we can select some translation in the X, and here we could put, like, let's say where is the translation in this direction? Okay, okay. See, we can the deformed shape, the original shape. Here's the little video. Okay, alrighty. Well, that's it for this video. Thank you guys for watching. Give it a thumbs up and like the video, which is the same thing. So let's see, subscribe. Yeah, that's the one that I wanted. Subscribe. Go ahead. All right. Thank you. Have a good one, everyone.